learners! Today we're going to do an experiment with milk, food coloring, and dishwashing liquid to learn about how dishwashing liquid works. The picture you see is what our experiment looked like at the end. So now let's begin. For this experiment, you need a large plate and you need to fill it with whole milk. Make sure it's whole milk. This is very important in order for the experiment to work. You also need food coloring, liquid food coloring, and 2 cotton balls, and you should put dishwashing liquid on top of it like we have over here. So now, let's begin. The first thing you're going to do is take your food coloring and pour drops of it in the middle of your plate as shown. They should all be in the middle, and do a few drops of each one. Don't put them on top of each other. So you should put them in kind of like apart from each other as shown. Now, take your cotton ball with your dishwashing liquid and obviously point the cotton ball so the dishwashing liquid is going to touch the plate, and place it in the middle. So as you can see, as soon as we placed our cotton ball, all the colors just kind of flew outwards. So then, after you let it do this for a while, we're going to take our second cotton ball and we're going to do the same thing in the middle to see if there's any further change. Okay, so we see a little more color difference. Now we're going to talk about why this happens. So how does the dishwashing liquid cause the milk to expand the way it did? Milk, to name a few, is made out of minerals, proteins, and fats. The scientific name for fats is lipids. Dishwashing liquid immediately tries to attach to lipid molecules in the milk. Later, we're going to talk about how dishwashing liquid works, and that'll help us understand more clearly onto why this happens. Because the soap is rushing to attach to the fat molecule, we see a cool rush of color. You may be asking why we're using food coloring if this reaction can occur without it. So the food coloring's only role is to show us so that we can see what's happening. Without it, it would still occur, but you wouldn't be able to see it as clearly. So the food coloring lets us see it. So now we're going to talk about how dishwashing liquid cleans dishes. In a soap molecule, one end of it is hydrophilic, which means that side likes water. And the other side is hydrophobic, which means it fears water, so it stays away from it. Lipids are also hydrophobic. If you've ever put a little bit of oil inside water, you'll see that it kind of balls up and it stays away from it as much as possible. So the hydrophobic end of our soap molecule attaches to lipids, and the hydrophilic end attaches to water. So because of this tendency for the hydrophobic end of the soap molecule to attach to lipids, that's why the dishwashing liquid rushed to go attach to the lipid molecules when we were doing our experiment. So now, back to why dishwashing liquids clean dishes. Because one side is attaching to lipids and one side is attaching to the water, the lipids are able to attach to the water with some help. So because the oils are now attached to the water, we're able to wash away the dirt from
the dishes, and if we're talking about washing our hands, then this is also how it works. So this is how our experiment works and how dishwashing liquid cleans dishes.